Okay, 6.2, the equation of a line standard form. When we're looking at the equation of a line, the equation of a line can be expressed in the form, the slope y-intercept form, which is y equals mx plus b, and it can be expressed in standard form, which is ax plus by plus c equals 0. Now there's some stipulations that we have to note. Y equals mx plus b tells us some important information about the graph. M and b are numbers that represent parts of a line. So example, the m represents the slope of a line and the b represents the y-intercept. When you have y equals mx plus b, that allows us to also graph the particular graph, because we would begin at the y-intercept and then we would follow the slope along the graph to be able to see the line that we need to make. So the y equals mx plus b, also known as the slope-intercept form, has very important pieces that help us understand the parts of a graph. Now sometimes, or oftentimes, a linear equation can be expressed in standard form. Ax plus by plus c equals 0 is known as the standard form. Note here, a, b, and c belong to the world of integers. What that means is, if you have to understand what integers are, I'll give you a little history behind numbers. When you first started to count and learn about numbers, you naturally began counting. You counted, let's say, on your hands. Then your world got increased into the world of whole numbers, that is 0 plus all the natural numbers. Once we get past the whole numbers, we got into a larger world that involved integers. Integers are all whole numbers and all natural numbers, including the negative versions of these numbers. Now, the world actually gets larger than this, which involves all the numbers that exist between these numbers, and that is known as rational numbers. You guys, everyone knows rational numbers as, for example, fractions, and basically any number that can be expressed as a fraction. Okay, those are known as rational numbers. Now, what's important to note is the a, b, and c here belongs to the world of integers. That means only a, b, and c can be integers. And even more impressive to note, the value of a must be greater than or equal to 0. Whereas y equals mx plus b, we could have had fractions to represent m and b. Whereas in standard form, a, b, and c have to be actual numbers, and specifically the a value can only be positive. So b and c can be positive or negative, but a must be positive in order to really reflect standard form. All right, now a, b, and c written in words can only be integers. So this is what this statement is saying, that a, b, and c can only be integers, and a must be positive. That's this statement here. So I'll underline this piece. This is a mathematical statement that means this in words. And this piece means this in words. So that you understand that standard form looks like this. We'll talk a little more about standard form in a little bit. Example 1. You're asked to convert to standard form the following questions. Y equals 2/3 x plus 5, and b, y equals negative 3x minus 5. Well, with the first one, first thing you have to do, folks, is get rid of the fraction, because there are no fractions allowed when it comes to standard form. So what do you need to do? Well, we need to note that you have to multiply each term by the lowest common denominator. That is, we take y and 2/3 x and 5, and we multiply each term by the lowest common denominator. That is 3, 3, and 3. Everything got multiplied by the lowest common denominator, which is 3. So you end up with 3y is equal to, now this next one's a little tough for people to understand, so we'll go through it slowly. 3 times 2, and then you divide by 3. Or 3 divided by 3, and then you times that by 2. The result will be 2x. And then finally, plus 3 times 5, which is 15. So we've multiplied each term by the lowest common denominator. Next step is to rearrange the equation, move the equation to the side where x is positive, so that x is positive. That's right. So we see that x is already positive here, so that means we're moving everything to the right side. 2x minus 3y plus 15 equals 0. 2x minus 3y plus 15 equals 0. And that, folks, is how you convert from any form to standard form. Multiply by the lowest common denominator, and then part B, the second part, is to rearrange the equation so that x is positive. Moving on. Part B, y equals negative 3x minus 5. Move everything to the side where x is positive. So step 1 was to multiply by the lowest common denominator. Do we see a denominator? No, because there's no denominator here with fractions. We don't have to worry about it. If it was decimals, we would have to multiply to get rid of the decimals. Here, folks, what we're looking at is we have just integers as coefficients and as a constant, so all we have to do is move things so that the x is positive. So 3x is going to move to the left side. 3x plus y plus 5 equals 0 is the equation. Let's try another one. Y equals 3/5 x minus 7/2. We need to convert this to standard form. We do this by A, looking for the lowest common denominator, and multiplying each term by that denominator. So each term gets multiplied by, that's right, 10. So we multiply by 10, and we get 10y equals 10 times 3 divided by 5, which is 6x, minus 10 times 7 divided by 2, 35. So we have 10y is equal to 6x minus 35. So we move to the side where x is positive. That will be the right side this time. And we get 6x minus 10y minus 35 is our equation. Okay, moving on. Example 2. Convert to slope-intercept form. So now we're going to convert to slope-intercept form. That means we're going to make y by itself. Looking at the first equation, we need to follow certain steps. So here's our standard form equation. We need to change it to slope-intercept form. Slope-intercept form, step number 1, is to isolate for y where y is positive. So we need to move to the side, the y to the side where y is positive. Y here is negative. We want to move the y over to the right side. So you have 5x plus 2 stays where it is, folks, equals 3y. Next step is to divide each piece by 3. That's right, divide each piece by 3. So 5x, make y by itself by dividing all the terms by the coefficient of y. So, one more time, we need to get y by itself. So we're going to divide by the number multiplied by y, so the coefficient of y. We're going to multiply each term by this 3. So each term gets divided by 3. So we get 5x over 3 plus 2 over 3, 3y over 3. Well, that gives me y equals, so again, y equals, and what do we have over here? 5/3 x plus 2/3. And that, folks, is the answer to this first problem. Moving on. Whether you write it this way or this way, folks, you'll still get it's the exact same answer, you will not lose any marks. As long as you have the same, everything exactly the same sign, same numbers, in the same order. Okay, next. 8x minus 2y minus 16. Oops, let's pause this, folks, and get back to the original. Here we go. 8x minus 2y plus 16 equals 0. We want to isolate for y, make where y is positive. That means everything, the minus 2y moves over to the other side. So we get 8x plus 16 equals 2y. Next, we're going to divide each piece by 2. Each term by 2. We end up with 4x plus 8 equals y. And that's the equation that results after all of this. So y equals 4x plus 8 is the final linear equation. Okay, moving on. 7x plus 14y is equal to 42. Oh, pause that. 7x plus 14y plus 42 equals 0. All right, step number 1, isolate y so that y is positive. That means that 14y is going to stay where it is. Everything else is going to move over. It's going to equal 14y equals negative 7x minus 42. That is, 14y is equal to negative 7x minus 42. Next step is to divide each term by 14. Divide by 14, divide by 14, and divide by 14. What do you end up with? You end up with y equals negative 7 over 14 is equal to negative 1 over 2x minus 42 over 14 results in negative 3. So the final answer to here is going to be y equals negative 1/2 x minus 3. All right, some interesting things to note. Remember earlier I said that ax plus by equals 0 also has some interesting facts that we're going to learn. Well, ax plus by plus 0 plus c equals 0, it tells you important pieces of a graph. That is, if I plug in, if I take the c value, I take negative c, so whatever's in the equation that I see here, I take the opposite of the c, negative c, over b, that will result in the y-intercept at all times. Why is that the case? Well, y-intercept means that x will disappear. So I'm going to cover it right now by making x disappear. X has disappeared, so you would have by plus c equals 0. Essentially, what I could do is move the plus c over, moves to negative c, and then divide by b to find my y-intercept. This is a fast way to find the y-intercept when you're given the equation in standard form. Another way is negative c over a. That is, if I know that I can find the x-intercept of the line if I cover up the y, so that ax is equal to negative c, and that x is equal to negative c over a. So negative c over a is the x-intercept of the line. Negative a over b actually tells us another important feature of the graph. It tells us, that's right, the slope of the line. So it's interesting to note that we could determine the x-intercept, the y-intercept, and the slope just by seeing it in standard form. Let's practice this a bit. All right, example 3. Express each in the form indicated and state the x-intercept, y-intercept, and the slope of each of the lines. So here we go with the first one and the second one. Oop, too much, folks. All right, here we go. Y equals negative 1/3 x minus 2, and we need to convert it to standard form. Find the slope, the x-intercept, and the y-intercept. In the second one, we have it in standard form, and we need to put it into slope-intercept form and still find the x-intercept, the y-intercept, and the slope. Okay, let's look at the first one. Well, the first one, we have to convert, 1 second again, we have to convert the first one to standard form. That means there can't be any fractions or decimals. How do we do that? Well, we multiply each term by the lowest common denominator. That is, we're multiplying everything by 3. So we have 3y is equal to negative x minus 6. So how do we get negative x minus 6? Let's do it. 3 times y. 3 times negative 1 divided by 3. So 3 divided by 3 is 1 times negative 1 is just negative 1x, or negative x. And then minus 3 times 2, which is minus 6. So we've now eliminated all the fractions and decimals. We end up with this, and we move to the side where x is positive. That is, x plus 3y plus 6 equals 0. And that is the equation in standard form. Now, the question also asks you to state the x-intercept, the y-intercept, and the slope. Standard form helps us to find those things quickly. That is, we know that a is 1, b is 3, and c is 6. So we can find the x-intercept, the y-intercept, and the slope knowing the formulas we just did. X-intercept has something 0. Y-intercept, so in this case it's going to be negative 6, 0. Why is that the case? Well, it's going to be negative 6 because we take negative c over a. To find the x-intercept, we cover up the b, we need negative c over a. Negative c is negative 6 over 1 is just negative 6. And that's why we have negative 6, 0 as our x-intercept as a coordinate. Our y-intercept will be, as a coordinate, 0 something, and that is negative c over b. What is negative c? Negative c is negative 6 over b, which is 3. Negative 6 over 3 results in an answer for our y-intercept of negative 2. So 0, negative 2 is our y-intercept. The last part is our slope, m equals. Well, in the original question, we could find out that m is equal to negative 1/3, but we can also do that using standard form. Standard form says our slope is going to be negative a over b. Negative a is negative 1 over 3, which is b. So m is equal to negative 1 over 3. We could have seen that in standard form, or we could have calculated that from, in slope-intercept form, you can find the slope easily, or in standard form, we could have calculated that. Either way, you will get the full marks. Okay, one more example. Let's try this one. 5x plus 2y minus 10 equals 0. Move it to slope-intercept form. That is, let's do the x-intercept, y-intercept, and the slope right away before we move it to slope-intercept form. So our x-intercept is going to be when y is equal to 0. Our y-intercept is when x is equal to 0. And our slope is going to be m. So our x-intercept is going to be negative c over a. Negative c over b is going to be our y-intercept. And our slope is negative a over b. So what are these values? Well, negative c over a is negative 10. Let's try that one again. Just a little bit. Negative c over... Okay, we can see negative c over a, negative c over b, negative a over b. So we need to identify the a, b, and c. A is 5, b is 2, and c is negative 10. So negative c over a is going to be negative 10, which is 10 over a, which is 5. So my x-intercept is 2, 0. My y-intercept is going to be negative 10, which is positive 10, over b, which is 2. What is 10 over 2? That is 0, 5. And finally, negative a over b is negative 5 over 2, and that is the slope for this particular line. Now, we can find the slope-intercept form equation just by looking at the information given here. We can find out that the slope-intercept form is y equals negative 5 over 2x plus 5, based on what I see here. My slope and my y-intercept will give the equation in slope-intercept form. Now let's say we were to do this and put it back to slope-intercept form. Let's convert it without looking at the answers. Let's see if our answer is correct. Well, the step is you have 5x. Okay, now what happens? Let's just look up here. We can see that 2y is positive, so leave 2y where it is. And what will we have on the other side? That is, remove the 5x to the other side. It becomes negative 5x. Negative 5x. And then we're going to move to the other side the minus 10. It becomes positive 10. And then what we're going to do next is divide each term by 2. Divide each term by 2 to get y by itself. That is, we end up with a result of y equals negative 5 over 2 x plus 5. And this will be the final answer. So one more time, let's redo that again. Y equals negative 5 over 2 x plus 5. And that, folks, matches the equation we had earlier. That's right. So whether we isolated for y or we used the information we got, we were able to find the equation in slope-intercept form. Okay, well, that's the end of the lesson, folks. Have a numerical day.